Have you ever stopped to think about how this explainer actually got to your screen? I mean, really think about it. The data for it traveled from a server maybe hundreds or thousands of miles away, right to the device in your hand, all in the blink of an eye. So today, we're going to trace that incredible, invisible journey, which all starts with a single click.
Right. So this explainer, it wasn't just summoned out of thin air the moment you hit play. Nope. This data has been on a serious trip. In many cases, it started in a massive data center somewhere on the other side of the country or even the world. And from there, it navigated a mind-bogglingly complex network, all to arrive right here on your screen. It's an absolutely extraordinary feat of engineering that we pretty much take for granted every single day.
So that's the big question, isn't it? How did it actually get here? What's the path? What is the technology that makes this kind of instantaneous global communication possible? Well, let's find out. We're going to trace the route.
Okay, first things first, we've got to tackle a huge misconception. You know, when we think about information flying through the air wirelessly, our minds often jump straight to space, to satellites. And it seems logical, right? A signal goes from a data center, gets beamed up to a satellite orbiting the Earth, which then beams that signal right back down to you. It sounds so clean, so simple, so wireless. But here's the thing. While that technology definitely exists, it is not how the vast majority of our daily internet works. And here is the biggest reason why. A typical communication satellite is parked in orbit nearly 22,000 miles above the Earth. So for your request to go all the way up and for the data to come all the way back down, it has to travel a staggering 44,000 miles. Now, that massive distance creates a huge problem, and it's called latency. It's basically the delay between when you ask for something and when it starts to show up. I mean, just think about online gaming or a video call. That 44,000-mile round trip would create this noticeable, super frustrating lag. It's just not practical for most of the things we do online.
So if it's not satellites, then what is it? Well, the truth is actually grounded, literally. The real backbone of the internet is this massive, incredibly complex global network of physical optical fiber cables, flashing data across the entire planet at nearly the speed of light.
Okay, so we've established there's a physical network of cables, but how does the data sent from a server find your specific phone or laptop among the billions and billions of other devices connected to that very same network? Well, just like a letter, it needs an address. And that is exactly what an IP address is. It's a unique string of numbers that acts as an identifier for a device. And I mean every single thing connected to the internet. From a huge server farm to the phone in your pocket, it gets one. It's the fundamental way your device can be found in this giant global network. And here's a really great way to think about it. An IP address is basically just like your home's mailing address. It is a one-of-a-kind identifier that tells the Postal Service exactly where to deliver a package. In the exact same way, an IP address is the unique shipping label that tells the network where to deliver a chunk of data. Now, this system is fantastic for computers. They love numbers. But for us humans, it's a huge problem. You don't type a long string of numbers into your browser to watch a clip or check your email. It would be absolutely impossible to remember the IP address for every single website you visit.
And this is where something called the Domain Name System, or DNS, completely saves the day. You can think of it as the internet's giant phone book. Just like you'd look up a friend's name to find their phone number, your browser uses DNS to look up a simple website name like youtube.com to find its corresponding machine-readable IP address. Without it, browsing the web would be a total nightmare. So we've got the route figured out and we've got the addresses sorted. But how does the actual data, this entire explainer, make the trip? It's way too big to travel as one giant file. This breaks down the whole process pretty nicely. It all starts when you type a website's name. DNS finds the IP address and your browser sends a request to that server. But here's the really clever part. The server doesn't just send the whole file back at once. Instead, it chops it up into thousands of tiny pieces, sends them over, and then your device puts them all back together again in the right order. These small chunks are called packets. See, trying to send data in one massive, continuous stream would be incredibly slow and inefficient. And if there was even a tiny error, you'd have to start the whole download over again. By breaking it into these little packets, the whole system becomes way more robust and way more efficient. And each one of these thousands of packets is like a tiny, self-contained package. Inside, it's got a small piece of the data, the sender's address, that's the server, and the recipient's address, that's your device. And crucially, it also has a sequence number. That number tells your device the correct order to put all the pieces back together, so the explainer plays smoothly and not like a jumbled mess. And this is where the pure genius of the internet really shines through. The packets that make up this explainer, they didn't all travel the same path to get to you. Not even close. Each one is sent out independently to find the fastest, most efficient route available in that exact millisecond. If one path gets congested with traffic, other packets just go a different way. It's what makes the internet so incredibly resilient and so fast. All right, let's zoom out for the final piece of the puzzle and see how this all comes together on a truly epic scale. We've talked about the journey of the data, but what about the road itself? The physical backbone of the internet is just an astounding feat of engineering. We're talking about specialized ships that lay these optical fiber cables across the ocean floor. They literally drop a plow to the bottom of the sea, which digs a trench and lays the cable directly into the seabed, physically connecting entire continents. But, a physical network is totally useless without rules. And these rules are called protocols. The best way to think of them is as the shared grammar of the internet. They are the agreed-upon rules for how to format packets, attach addresses, and basically ensure that every single device, anywhere in the world, can speak the same language and understand each other. And to stop all these names and numbers from descending into total chaos, the global system needs a coordinator. That's the role of an organization called ICANN, the Internet Corporation for Assigned Names and Numbers. They manage these core systems, making sure IP addresses are unique and overseeing the entire domain name registry to keep it all running smoothly. So there you have it, from a data center, broken into thousands of independent packets, each one finding its own best path through a physical web of undersea glass fibers, all governed by a shared set of rules, and finally reassembled perfectly on your screen. It is a truly, truly amazing journey. So the next time you click a link, just for a second, remember what's actually happening. You are activating a connection to a real, physical web of glass cables that are stretching across continents and deep under the sea. It kind of makes you wonder, right? Knowing how it all works, what will you explore next?